So next section is 2.5a, polynomial equations and equation in quadratic form. So we're going to have a little mixed of equations in this situation, but not a lot of it that you have not seen yet. So it's just more practice and some a little bit of difference in when in the approach of solving polynomial function, and you're gonna see higher degree than when it was just a quadratic equation. So let's get started with this first example where they say solve the following polynomial equation and give the solution set by separating the solutions when you have by comma sign when you have multiple solutions. Well, this equation, first thing that you need to check is the variable is you have more terms that have the variable. And then the second thing is that sometimes you have different exponent for the variables. Whenever you have that, you need to put the equation in standard form, meaning that 0 on one side and everything else on the other side. So for this, we're gonna add 6 on both sides to get 0 on the right side. And after that, the equation becomes x squared, x to the third, minus 2x squared, minus 3x plus 6 equals 0. At this point, the only tool that we have to solve equations that have that have 4 terms, the only tool that we have at this point to solve equations with 4 terms on the left side is factor by grouping. I mean, we know when we have 4 terms, we can factor by grouping. And since this is the only thing that we know at this point, then we're going to try if it works. Obviously, there's no chance that it wouldn't work because that's the only tool that we have. So we group. That's the first group. When we have more tools, then we would have multiple options. But at this point, this is the only option that we have. What's the GCF of the first group? Did you say x squared? Obviously you did. So x squared out. So that's x minus 2. GCF for the second group. You have to pull out the negative sign when the first term sign is negative. So we are going to minus 3 outside, and then inside will be x minus 2 equals 0. X minus 2 repeats, then we can factor it out again. So that's x minus 2 factor x squared minus 3 equals 0. Now we can use the zero product property. Remember, if A times B equals 0, then A equals 0 or B equals 0, right? So that's our A times, and that is our B equals 0. So put this in blue as a comment. So that means x minus 2 equals 0 or x squared minus 3 equals 0. We're going to add 2 on both sides. X equals 2. And then we're going to add 3 on both sides. X squared equals 3. So that means what? The square root property, if square root of if A squared equals B, then when you take the square root of both sides, there will be a plus minus. So A equals plus minus square root of B. right? You remember that. So here, x equals plus minus square root of 3. So we have three solutions, 2, square root of 3, and square root of negative square root of 3. So we have three solutions in this case. I love to give my solutions here, 2, square root of 3, negative square root of 3. And then we can also give it as a solution set that is for the first example. So the next example here, it's already in standard form. All the variables are on one side. And because we have different exponents, we're gonna have to put it in standard form. That's why we checked this. And now we got four terms. You know, when you have four terms, and at this point, the only tool that you have is factor by grouping. So we're gonna start by factor by grouping. Well, if I group these two together, I will get the second group. That's this. GCF of my first group here is just x squared. When factoring x squared out, I'm gonna have x minus 7. And then the second group, GCF, looks like 9, right? Well, actually, when I factor x squared out, I'm gonna have 2x here minus 7. And then when I factor the GCF for the second group, which is 9, so plus 9, I would have 2x minus 7 as well equals 0. 2x minus 7 repeats. I will refactor the 2x minus 7 out. So what's left would be x squared plus 9 equals 0. We can use the zero product property. 2x minus 7 equals 0, or x squared plus 9 equals 0. If I add 7 on both sides here, 2x equals 7, and divide by 2, x equals 7 halves. Or if I subtract 9 on both sides, we get x squared equals negative 9. By taking the square root of both sides of this equation, I will have, remember this is square root of negative 1 times square root of 9. Negative x square root of negative 1 is I, and square root of 9 is 3. So this is x equals 3i. So then equals 3i. Let's re-verify this. Yeah, equals 3i. Let's check again. That's this and that. Factor 9. See here. Perfect. So, and then now that's the two solutions, but we do need the plus or minus, right? We do need the plus or minus, correct? And then that is the set of solution that is 7 over 2, 3i, and minus 3i. So your solutions are 7 over 2, 3i, negative 3i, or in solution set, 7 halves, 3i, negative 3i. So now next example is given in this format. that we want to make sure that we put in standard form, 0 on one side and everything else on the other side, because the degrees are different and multiple terms have the variable. So we're gonna subtract 54x on and add 45 on both sides. Subtract 54x and add 45 on both sides. Then we have 6x cubed minus 5x squared minus 54x plus 45 equals 0. We can factor by grouping again. Remember, that's the tool that we have for at this point whenever we have higher degree equations, mostly when they have 4 terms. And then the next group would be that. What's the GCF of the first group? Obviously, the numbers, they don't have any common factor except for 1. So that's going to be only x squared. That's 6x minus 5. And then GCF of the second group, I'm going to pull out the negative sign since the beginning term has the negative sign. So that's negative. And the common factor for the two will be 9. And then they don't share, both of them don't have variables. So this group will not have a GCF that has the variable. So factor out 9, right? Negative 9 if you want. And that's 6x minus 5 equals 0. We will factor the 6x minus 5 again. X squared minus 9 equals 0. Use the 0 product property. 6x minus 5 equals 0, or x squared minus 9 equals 0. So both of the equations, by adding 5 here, I will get 6x by itself. And then if I divide by 6, x equals 5, 6. And then over here, if I add 9, x squared equals 9, and the square root of both sides would give me square root of plus minus square root of 9 on both sides. Obviously x squared, square root of x squared. And then x equals plus minus 3. We have 3 solutions. One is 5, 6. The other ones are 3 and negative 3. And I can list my solution as 5 over 6, 3 and negative 3. The order does not matter. Or in solution set, 5, 6, 3 and negative 3. In example number 4, I realized that this problem is a little different from the ones we've done so far, but not quite so. Well, say it is, but the presentation is different. Now, because we see that, we can ask ourselves the question, what is different here that we've not seen so far? I have not seen this, the radical of x inside of the equation like this. But, well, radical, I can remind you that radical of z is the same as z to the power 1/2. And remember what I told you is whenever you have equations to solve where you have different exponent for the variable in different terms, you may want to make sure your equation is in standard form, which means 0 on one side and then the constant on the other side. Now, when you do that, it will require you to think a little deeper. Now, I want to remove this in my equation. So that's why I'm gonna call this something else. So I'm gonna call, and we call this change of variable. So we process by changing the variable. So change of variable, it allows you to bring another variable in your equation that makes it easier for you to solve the problem, but you don't want to forget that you are solving for a variable that was not your initial variable, so that you can go back to that initial variable to present your solution. So we change the variable here from z, and I'm gonna solve it for u, for example. Let me call square root of z equals u. Now, if square root of z equals u, I can square both sides to call z now u squared. Because if I square both sides, when I square root of z, it's z, and when I square u, it's u squared. Then I have z and square root of z. Z is u, and square root of z is u, and z is u squared. Now I'm going to solve my equation in u, thinking that whenever I find u, since there is a relationship between u and z, I can quickly go back from u to z to present my solution. I don't want to forget that point. Okay, so here, let's start this. Back to my equation, z is u squared, and square root of z is u. My equation becomes u squared minus 5 times u minus 25 or 4 equals 0. This is one of the quadratic form that we had. And we can solve it by factoring. What are two numbers to multiply to get negative 24 and add to get negative 5? A little bit of thinking. Obviously, it's not so hard to think and you can play with it. Play with it. Play with the factors, right? I don't know if you start by 6 and 4. 6 and 4, one of them, because you want negative 24, one of the factors should be negative. Let's see if negative 6 is 6 takes the negative sign. Well, when we add, it's not going to be negative 5. So negative 6 and 4 won't work. Let me try 6 and negative 4. 6 and negative 4. Both of them, well, I mean, this will not work either, because that's going to be positive 2. I'm looking for negative 5 when I add them. When I add 6 and negative 4, it's positive 2, then still not working. And you play with the factors all the way through, and you would end up having the right pair that is negative 8 and 3. Quarter is negative 24, and sum is negative 5. Well, now I have the two factors, bring them here in the equation, so I can get 4 terms and factor by grouping. So that's u squared, or if you want to go quicker, since coefficient of u is 1, you can just direct factor this as u minus 8, u plus 3 equals 0. Or if you factor by grouping, it would give you the same scenario. But that's quicker if you want to use it. That's the direct factor method. And you can use the zero product property. That's u minus 8 equals 0. Or u plus 3 equals 0. You would have the two solutions here by adding 8. U equals 8. Or here by subtracting 3, u equals negative 3. U was not our previous variable. So these are not the solutions yet. We need to go back to the change of variable that we had over here and say, okay, so u now is 8. So that means square root of z equals u, but we had u is 8. Then if you raise both sides to the second power, z will be 64. But in the other situation, we would have square root of z equals -3, which is impossible. The square root of a number, it must always be positive, I meant. Must be positive. So we found something that's impossible. So this will not provide any solution here. So your solution set will be the single element solution is 64. So your solution is 64, or your solution set 64. Then you need to pay attention. Two things that you need to pay attention to. Well, when the equation is presented in a format that's, weird, if you want to say, then you may want to transform it. Use the change of variable to bring it to something regular so you can solve it. This is going to be a case where you have something that is not the same variable that you started with. And if you make the mistake giving the solution based on the solution you get from the variable that you brought into your equation, it's wrong. You always have to go back to using the relationship that you have between the two variables and use it to go back to your previous variable, and that's going to be the solution of the problem. And in some cases, some of them may not even work. But because you had it, that doesn't mean it's going to be used for the final answer. So make sure you pay attention to that little comment that I put here, and that is very important. Let's see another example. In this example here, we have some weird thing again. Well, when you have weird situations, you may want to transform it and bring it down to something that is easier to solve. Exponent radical, rational exponent. So I'm going to make sure that I write this as x to the power 1/3 squared, see, and minus 4 x to the power 1/3 equals 21. That I see I can call x to the power 1/3 something, and then it would erase the level of weirdness of this equation. Let me call x to the power 1/3, some simple stuff, t, for example. Well, that would mean what? X to the power 2/3 will be t squared if I raise both sides to the power 2. Then life is getting better, right? And then now we can go ahead and bring the t into my equation. And that's the mistake you don't want to make. After you bring t into your equation, t is not your variable you're solving for. It's an intermediate variable that allows you to solve, and then this previous relationship between the two will allow you to bring it back when you get the t. You're solving for t and then bring it back to the previous variable that was x. So my problem becomes t squared, right, minus 4t equals 21. This one, I'm going to solve it using the complete the square. Remember, we talked about it in lesson 2.4b, right? So I'm going to use it here. So I'm going to add, so t squared minus 4t. I'm going to add, what is 4 over 2 squared? That's 4, correct? So I'm going to add 4 on both sides. which doesn't change my equation given that I balanced it, right? Adding 4 on one side and whatever I do on one side, I do it on this on the other side, makes it still the same thing. Now, in perfect squared form, we know that's 25, obviously, makes it easy, right? It looks like something that's going to be very nice. And then the square root of this is t, the negative sign, and then the square root of this is 2, right? All right, so then that takes me to the radical square root property form. If I take the square root of both sides, the plus or minus here, and then that will take me to t minus 2 equals plus minus 5. If I add 2 on both sides, t equals 1. 2 plus 5, that is 7, or t equals 2 minus 5, that is negative 3. Two solutions, 7, negative 3. And then the next example is kind of similar to the first one, the one we just did. It's kind of similar to it. So we're gonna go, we're actually, let me see. Yeah, I made the mistake that I was telling you not to make. What is it? That's not the solution. That is not the solution. That is not the solution. Why? Because t is not your variable. I'm glad I made this mistake so we can talk more about it and I can draw your attention deeper to this, because you may, I mean, after you get that, you may feel so comfortable, forget about that you brought the t into your equation, but t is not. It's not it. Let's bring it back here. So t is x to the 1/3 power. So then we're gonna have two situations, right? Two situations where x to the 1/3 equals 7, or x to the 1/3 equals negative 3. Now, to get x, we're gonna have to raise both sides to the power 3 to cancel that power 1/3, right? Yes? Then that's gonna be x equals, what is 7 to the 3rd? 7 raised to the 3rd is 330, is 330, 343. And then the other one, x, is going to be negative 27. So your solutions are negative 27 and 343. So that's your actual solution, negative 27 and 343. Or in solution set, negative 27 and 343. Watch out. There's a lot of room for you to make mistakes here, and then you have to make sure you be careful after you get those solutions from the variable that you changed, to know that this is not your actual variable. And then because of that, we're gonna do another example in using the same type of equation. That's the same thing here. We're gonna change it. I'm going to change a variable here. Let me change x to the 1/3 as v, for example. I'm just using something else. I could use t also. Well, if that, then x to the 2/3 is going to be v squared. Now my problem becomes 5v squared minus 3v minus 2 equals 0. For this one, I'm going to use factor by grouping. So that means I'm going to multiply a and c. Well, obviously a equals 5, b equals -3, and c equals -2. I multiply a and c. AC equals -10. Two factors of -10 that the sum is -3 are -5 and 2, right? Now, I'm going to write it as 5v squared minus 5b plus 2v minus 2 equals 0. I have 4 terms. I can factor by grouping. First group is the first 2 terms, and then second group is the last 2 terms. GCF of the first group is 5v, so that's v minus 1. GCF of the second group is 2, and v minus 1 equals 0. So v minus 1 factored again. So then I have 5v plus 2. How you factor does not bother me at all. I just use one thing that I feel more comfortable doing. Well, when I say more comfortable doing, I can do both, all of them, but I think this will be easier for you to keep track of. That's why I use the factor by grouping, and that's one of the methods that most teachers or professors don't use, and I want you to practice more to see the beauty of it. That's why I use it. But if you use other methods that you feel you're more comfortable doing, I am 100% fine with it. So just so you know. And now the zero product property, v minus 1 equals 0, or 5v plus 2 equals 0, plus 2 equals 0. So v equals 1, or v equals -5 by 2 over 5. And you know, we need to go back, right? We need to go back. So we had v equals x to the 1/3 power. So x to the 1/3 power equals 1, or x to the 1/3 power equals -2 over 5, raising to the third turns x to 1, no big change. And then here, x is -8 over 125. -8 over 125 would be the other solutions, the other solution, and the solution set 1, -8 over 125. And then 1, -8 over 125, or solution set 1, -8 over 125. So this is this ends the section 2.5a, and then we're gonna start the 2.5b in our next video.